Welcome to this video in the Solutions chapter, Colligative Property Calculations. This video is going to delve into the calculation of the new boiling point and freezing point after the addition of a solute to a solution. To effectively learn what you need to in this video, you will need to take out part 2 of your companion worksheet number 13.4. You will need a C-cert periodic table, a calculator, and of course, you guys are going to need your notes. So without any further ado, let's learn some chemistry. So thinking back to our last video, we focused on the qualitative effects of adding a non-volatile solute to a solution. And we saw that vapor pressure, boiling point, and freezing point were changed. We saw that the vapor pressure was lowered, the boiling point was increased, and the freezing point was depressed. And the amount that they were changed really depended on the amount of solute particles that were actually dissolved in the solution. Well, in this video, we're going to focus on the quantitative aspects of colligative properties and actually calculate what that change is. How much does the boiling point go up? How much does the freezing point go down? So these are two new formulas that we are going to need for this lesson. Pause the video now and then unpause when you got them jotted down on your companion worksheet. So the first thing I want to talk about are the variables that are in these formulas. Some will look pretty familiar to you. For instance, delta T, which you can remember from enthalpy and Q equals MC delta T, is our change in temperature. It is how much the boiling point will go up or the freezing point will go down. You will also recognize the italicized M, which is your molality of the solution. Remember, molality is calculated moles of solute over kilograms of solvent. You guys should also remember the little I. No, it is not an imaginary number. It is the Hoff Factor. The letter I represents the number of pieces that our solute breaks up into when it is dropped into water and dissolves. Couple things to be aware of. You can see here there are 3 examples of typical solutes that are dissolving in the presence of water. You'll notice that this is table sugar, table salt, and calcium chloride. Remember this, if you have a molecular compound, covalent molecular compounds do not break up into their component atoms that are here. They stay intact as a molecule, so their Van Hoff value is 1. That is unlike ionic compounds, which will break up into their constituent ions. And if we look at this all here, we can see the calcium chloride, even if we put in 1 mole of each of these, is going to have a Van Hoff value of 3 due to the fact it breaks up into 3 pieces versus this, which would be 2, and this molecular compound, which would be 1. The 2 new variables that you will not recognize are Kb and Kf. Kb is what we call the molal boiling point constant, and Kf is the molal freezing point constant. And if you look at the units for these 2 that are down here, every 1 molal of dissolved solute will change the boiling point of the solution by 0.52 degrees Celsius. Every 1 molal of dissolved solute will change the freezing point or depress it by 1.86 degrees Celsius. So to make that a little clearer to you guys, essentially if you had 1,000 grams of water, which is a kilogram, and we dissolved a mole in it of particles, right, the boiling point would not be 100 degrees. It would be 100.52. So it would be slightly elevated. If we took the same mole of dissolved particles in the same 1 kilogram of water, that would depress our freezing point by 1.86 degrees Celsius. You guys can see it is far easier to depress the freezing point than it is to increase the boiling point. All right, let's move on to our calculations. If you guys look at your companion worksheet, we're going to take off with question number 3. Question 3 says, what is the new boiling point of a solution that is made by dissolving 1.20 moles of aluminum chloride in 750 grams of water? Pause the video now and see if you can determine what the new boiling point of this solution is by using this formula here. All right, I hope that wasn't too bad for you guys. Let's take a peek at how we did. If we look at the answer right down here, it says the new boiling point will be 103.33 degrees Celsius. Now, how do we get that? Well, let's look at this. First thing I had to do was decode the question, and I saw I was given moles, and I was given my mass of water, and I know I need molality for this, and in order to solve for molality, first thing I got to do is turn that 750 grams into kilograms. So when I go and set up my molal calculation, it's 1.20 moles of aluminum chloride over 0.750 kilograms of water. And to three significant figures, that gets me 1.60 molal. The next thing I have to do is figure out what my I value is. Well, I know my solute is aluminum chloride here, and it's ionic, and in the presence of water, it's going to break up into 1 aluminum and 3 chlorides, so that gives me an I value of 4. Pretty straightforward when you consider that. The last thing I got to do is remember what in God's name is my molal boiling point constant, and I know that it's 0.52 degrees Celsius per molal. So when I drop that in here, my calculation looks like this: 0.52 times 1.60 times 4, and gives me a delta T of 3.33. Do not write 3.33 as your final answer. That is your change in boiling point. You must add that to 100 degrees. And remember the rules of significant figures. That with addition and subtraction, I can only go out as far as my number that has the least number of decimal places. Since the 100 has infinite sig figs, I have to go out to my hundredths place, which is the 0.33 that's here. And that gives me a new boiling point of 103.33 degrees Celsius. Not too bad. All right, try this next question. Take what you learned and let's see if we can calculate the new freezing point. Same conditions. Pause the video now. All right, hopefully that wasn't too difficult. Let's see how you did. If you got the freezing point of minus 11.9 degrees Celsius, then you did the right thing. If you didn't, make sure you mind your numbers that are here. Make sure you use the right molal freezing point constant, which is negative 1.86 degrees Celsius per molal. All the rest of the info from the last question was the same. Okay, moving on to the next question. This one's a little more difficult. Question 5 says, I have 125.5 grams of table sugar sucrose, and I'm adding it to 1,000 grams of water. 1,000 dot, because we love our sig figs. When making rock candy, calculate the new boiling point of the water. Pause the video now and see if you can get it. If you got 100.1908 degrees Celsius for the new boiling point, you did it correct. Lots to dissect in this one. First thing I had to do is I was given grams of a solute, and I was not given moles. So I actually had to calculate how many moles 125.5 grams of table sugar winds up being. You'll see 4 significant figures. I get 0.3670. I then had to take that and plug that into my molality calculation, which is moles of solute over kilograms of solvent. You'll see that the 1,000 grams is 1 kilogram. I get a molality of 0.3670. Then I had to go calculate my value for I. I'm looking at my solute. It begins with a carbon. That means it's molecular. That has an I value of 1. So I'm plugging all these things into my calculation, and you'll see that I get, well, not a very large number, 0.1908. I add that to the 100 degrees, and I get 100.1908 degrees Celsius. Let's try the next one. In this next problem, we're going to calculate not only the new boiling point, but the new freezing point. And it's like bonus hour here. I actually gave you the molar mass, so you don't even have to calculate that. So pause the video now, give this a shot. If you wound up getting these two answers, if you got 100.509 degrees Celsius for your boiling point and minus 1.82 degrees Celsius for your new freezing point, I'd say you are 100% on track with these colligative property calculations. So in order to get really good at this, we're going to throw the kitchen sink at you. That is on worksheet number 10.1. It's not 10.5, silly. Make sure we knock this out for the next time that we meet. And in case you guys have any burning questions, we can certainly hit those as well. So I hope you have enjoyed calculations for colligative properties. I've certainly enjoyed being here with you guys. We'll catch you on the next video. Peace out!
That's all, folks.